Good morning. I am Raana, Assistant Professor in the Department of Computer Science and Engineering at Jhulelal Institute of Technology. Today's topic of discussion is symbol table design. It is a topic under language processor. Now, first question that arises in our mind is compiler role. What is the essential function of compiler? So, the essential function of one of the essential function of compiler is record the variable names used in the source program and collect information about various attributes of each name. These attributes may provide information about the storage allocated for a name, its type and its scope, procedure name, number and types of its argument, the method of passing each argument and type returned. So, what exactly is symbol table? Symbol table is nothing but a data structure which is used by a compiler to hold the information about the source program construct, or we can also define it as symbol table is a data structure used to keep track of scope and binding information about the names. Symbol table is its necessary component because declaration of identifier appears once in a program, but it is referred various places in a program. It is also used of identifier may appear in many places of the program text. Information provided by the symbol table. Given an identifier, which name is it? What information is to be associated with a name? How do we access this information? These are the three major questions that are associated with the symbol table. So, let's discuss each and everything one by one. What are exactly names? Now, name may be a variable and a label. It may be a parameter, may be a constant, record field, procedure, and array and file name. Now, as we are having a various category of names, the information that we have to store about the each name are categorized as follows. Now, each piece of information associated with name is called as attribute. Attributes are language dependent. Different classes of symbols have different attributes, like variable constant having attribute type, line number where declared, line where referred, and scope information. If your name is procedure or function, the attribute may be number of parameters themselves, and result type. And if the name is array, we need to store information about the upper and lower bound of the array. Second question is, who creates symbol table? Identifiers and attributes are entered by the analysis phase when processing a definition of an identifier. If your language is a simple language, then the declaration is always a global and implicit declaration. In this case, the scanner can enter an identifier into a symbol table if it is not already there. In case of a block structure language, in block structure languages with scope and explicit declaration, the parser and or semantic analyzer enters identifiers and corresponding attributes. Let's consider the example of C. In C, some name can be used as a variable and as a member name of structure in same block. Lexical analyzer only returns the name to parser rather than pointer to the symbol table. So, symbol table record is created when the name's syntactic role is discovered. Now, what is the use of symbol table? Symbol table is used in various ways. Symbol table is used by the analysis and synthesis phase. It is also used to verify that the identifier is defined. It is also used to verify that expression and assignment are syntactically correct, like in type checking. And one of the major use of symbol table is to generate intermediate and target code. How to implement the symbol table? Now, as we know that each name consists of various attributes. So we store this information in terms of records. Each entry in the symbol table can be implemented as a record consisting of several fields. These fields are depend on the information to be saved about the name. But since the information about a name depend on the usage of the name, the entries in the symbol table record will not be uniform. Hence, to keep the symbol table record uniform, some information are kept outside the symbol table and pointer to the information is stored in the symbol table, as shown in the diagram. As there is a name A of type integer, the information about the name A and type information is stored within a symbol table, and there is another information, lower bound and upper bound, which is stored outside the symbol table, and there is a pointer to the symbol table pointing to that location. A pointer stirs the symbol table to remotely store information for array A. Where should name be held? If there is modest upper bound on the length of the name, then the name can be stored in the symbol table record itself. But if there is no such limit or the limit is rarely reached, then the indirect scheme of storing name is used. A separate array of character called a string table is used to store the name, and a pointer to the name is kept in a symbol table record, as shown in a figure. In this case, there are two records associated with a two name. Let's consider first name AB. The first record shows the entry of name AB, where the name AB is stored in a string table, and the remaining information is stored in symbol table and somewhere outside the symbol table. Next important question is, or the important point is, to store the scope information. How to store the scope information in symbol table? First question is, what is scope? Every name possesses a region of validity within the scope program called the scope. Symbol table typically needs to support multiple declarations of the same identifier within a program. The scope of a declaration is the portion of a program to which the declaration applies. We shall implement scope by setting up a separate symbol table for each scope. Now, there are some rules to store the information about the scope of a name if the language is a block structure language. First rule is, a name declared within a block B is valid only within B. Second rule, if block B is nested within B2, then any name that is valid for B2 is also valid for B1 unless the identifier for that name is redeclared in B1. The scope rules required a more complicated symbol table organization than simply a list association between name and attribute. Each table is list name and their associated attribute, and the table are organized into a stack. So here we are using this stack to store the symbol table for each and every block. Now let's consider an example. Here, the program consisting of three blocks: main, procedure P, and procedure Q. The program main is the outer block consisting of three names X, Y, and procedure P. The last, as shown in a figure, the last symbol table for main consisting of information about X, Y, and P. As the block P is within a block main and it is another block, a different symbol table is created for the procedure P, which consisting of variable name X, A, and procedure P. As the procedure Q is within procedure P, there is a special entry in a symbol table of procedure P for name Q. In the same way, there is another symbol table for block Q consisting of a name entry X, Y, Z of type real. Now how to store the scope information if there is a nesting depth? Another technique can be used to represent scope information in a symbol table. We store the nesting depth of each procedure block in the symbol table and use procedure name and nesting depth pair as the key to access the information from the symbol table. A nesting depth of procedure is a number that is obtained by starting with a value of 1 for the name and adding 1 to it every time we go from an enclosing to an enclosed procedure. This number is basically a count of how many procedures are there in the referencing environment of the procedure, as shown in a figure. The outer procedure having a nesting depth 1, so the name that appears in outermost block also having nesting depth 1, as shown in a figure. X, Y, P are the members of the outer block, or the names appear in the outer blocks having nesting depth 1. Now, as procedure P is within the main block, its nesting depth becomes 2. 1 plus 1, 2. So, the name that appear in procedure P, which are X, A and Q, having nesting depth 3. In the same way, the nesting depth of the names that appear in procedure Q is 3. What are the data structure that we require to implement the symbol table? So, for deciding the data structure, we need to consider some issues. What are the operations that are required to process the symbol table? There are following operations like insert, which is used to add a record in a symbol table. Lookup, it is nothing but a search operation which is used to find symbol in a symbol table. Now, insertion is done only once, so the time complexity to insert the record in a symbol table is O of 1. Lookup is done many times. Whenever the name encounter in your program, your compiler will perform a search operation in a symbol table to check whether the name is already appear in a symbol table or not. For this, we need a fast lookup operation, and definitely the data structure should be designed to allow the compiler to find the record for each name quickly and to store and retrieve data from the record quickly. So there are some data structure that we can use to implement symbol table, like linked list. Now, a linear list of a record is easiest way to implement the symbol table. A new name are added to the symbol table in the order they arise. Whenever a new name is to be added, it is first searched linearly or sequentially to check if or the name is already present in the table or not, and if not, it is added accordingly. Now, the time required to add the new record if we are using the linear list is O of n. The advantage of using the linear list is it required less space and addition are simple, but there is disadvantage also, which is higher access time. If your list is unsorted list, so the time required for the lookup operation is O of n. If the list is sorted list, then the time required for the lookup operation is log 2n. As if the list is unsorted, we have to perform a linear search, and as we know that the time complexity required to perform a linear search operation is O of n. But in case of sorted list, as the data is in sorted form, we can apply the binary search, and the time complexity to find the record using a binary search is log n base 2. Next is search tree. efficient approach for symbol table organization is searched.